In this video, we're going to go through the process of assembling this circuit, which is a second order active low pass filter on a breadboard. And like in some of the previous videos we've done similarly, this isn't much of a theory video. We're not going to go too much into this circuit and the theory behind it, but rather just go through the process of assembling on a breadboard for those who might not be so familiar with breadboarding or prototyping using these boards. We have a previous video where we introduce the general principles of breadboards and how they work, so it's worth watching that if you haven't done so already. Okay, so this circuit here, I've printed out a sort of schematic from a simulation here, uses an operational amplifier, which we have here. And what we're going to be using is a 741, I'll write this off to the side, a 741 operational amplifier. Now, the particular model of operational amplifier that I have here is a I don't know if you can see that in the video. It's a UA 741, and to be honest, even if you use the more conventional LM 741, it won't make any difference for the purposes of this video. But what we find is, regardless of which particular model of 741 operational amplifier we use, we're going to be referring to this pinout diagram. So unlike the previous videos where we've assembled things like transistor amplifiers and simple diode circuits, this circuit involves the operational amplifier, which is a dual inline package with 8 legs. And so what we're going to do is we're going to start with this component, because what we can see is kind of everything else connects to it in some sense. It's like the core of the circuit. And so what I want to do is, first of all, get this component in situ. And there's a few things to bear in mind when doing that with a breadboard. First of all, these components are marked in order to determine which direction they go in, or which leg is which. And the way that they're marked is one of two ways. They've either got, if you can see on the diagram here, on the top of the chip here, they've got some kind of dot that's near leg 1, or on the other hand, they've got some little notch in the end, which this doesn't, but I'll just sort of draw one on. You'll see some little notch cut out of the end of the body of the package there, and that denotes which direction to orient the chip in. In most cases, we're going to orient that end to the left on our circuit as we look at it. These legs, as they come sort of shipped, are probably just too wide for a breadboard, so if you can, just very gently just sort of pinch them in a tiny little bit, and I'm talking just a couple of millimeters really. Just narrow the gap between the legs just by squeezing the two sides together. We'll find that they then sit nicely in place. So what we said was that sort of notched end, or the dotted end, goes to the left. And the way that we count the legs, or the number of the legs subsequently, I'll just grab something very narrow here to point. I'll use one of these wire links. What we're going to do is count from the bottom to the left to the right. So 1, 2, 3, 4. And then back down the other side, 5, 6, 7, 8. And what we see is that corresponds with this pin diagram that we saw earlier. So we're orienting in that way. There's that notch again that I mentioned before. 1, 2, 3, 4, 5, 6, 7, 8. So what we're doing is we're setting that up first of all, and we're going to put the other connections in place with respect to that. Let's have a look at our diagram here, because there's a few things going on. We have these two sort of filter stages made up of resistors and capacitors, and these two stages match as it stands. We've got 2 resistors that are both 1.2K, and we've got 2 capacitors that are both 33 nanofarads. They're the only sort of discrete components we need otherwise in this circuit. We're going to apply an input, which we'll talk about in a subsequent video. We're just sort of building it for the purpose of this video. We've got an input which we'll connect later. We've got a power supply here. In this schematic, they're both noted as 12 volt DC power supplies. Again, like previous videos, I'm going to try and get away with just using 9 volt batteries. And so I'll need 2 batteries in this instance, but they're both going to be 9 volts rather than 12. Everything else, I think we can build it as it looks here. So one other thing to mention is we've got 2 power supplies here, and the question is why? Well, if you have a look on the right-hand side of the diagram here, what we can see is we've got these 2 9-volt batteries sort of about this ground connection, which is in the middle. And we're taking the ground as 0 volts. So here's our sort of 0 volt connection. And what we mean by that is if we connect a power supply, let's say it's a 9 volt power supply or a 9 volt battery, with respect to 0 volts in this direction, then the voltage up here will be 9 volts. That's fairly common sense, hopefully. But on the other side, we've got this 9 volt battery in the same orientation, but with respect to 0 volts, it's reversed. In other words, I've got the mirror image there, and we're starting at 0 volts. Here's our 0 volts, but we have a sort of negative orientation of the battery when we're looking at it the other way around. And so our bottom rail here is going to be minus 9 volts with respect to that 0, what we're defining as 0 or ground here in the middle. So the reason I'm using these 2 batteries is because we've got what's called a dual rail power supply. So rather than just having 0 and 9 like in previous circuits that we've built, we've now got 0, 9 and minus 9. And we need that for the operational amplifier because the operational amplifier has a dual rail power supply. It requires a positive and a negative for the purposes of what we're doing in this video today. So let's bring back our circuit here, and let's also refer to our pinout diagram, and we'll need all 3 to get this right. But one of the first things we can do is we notice we have our V plus and our V minus connections for the positive and the negative connections respectively. And so what we can do is we can go ahead and connect those straight away, because we can see on our pinout diagram, this on our schematic rather, the top connection to the op amp there is our plus and the bottoms are minus, and so they connect to the plus and the negative rails respectively. So what I'm going to do, just in setting this up, I'm going to use 2 battery snaps for these 2 batteries, and what I'm going to do is I'm going to connect one from the top, so my plus 9 volts, to what we're going to call 0. And 0, you'll notice there's 2 rails at the bottom. We've only ever used 1, but I'm going to use both in this instance. That top rail along the bottom, so the second bottom row as it were, I'm going to call that my 0 volts or ground connection as it were. And so what we have in the first instance is plus 9 volts to 0, and then the other one goes from 0 to minus 9. Notice they're both in the same orientation, so it's let's try and get this in place. We've got from the top rail, I've got the red, the positive, connected to 0, going to this time the bottom rail, the very last row there, is going to be our minus 9 now. So now we have this dual rail connection. Just before anything else, I've just spotted a little issue that I've mentioned previously in one of the introductory videos actually, and I've gone and made the same mistake here. One of the things we mentioned is that this rail on this particular breadboard doesn't extend all the way along the breadboard. So you can see maybe the gap even in the red and blue lines there. The gap there means that the rail doesn't conduct all the way along. These are 2 separate rails as it were. And so what I want to do before anything else, I want to move this over to this side, or the alternative is I could move those battery snaps over to this side, the same result. But just for the sake of ease, I'm going to take that out of there. I'm going to put it over somewhere on this side, which is a bit more sensible. Okay, so back to these dual rail power supplies, sorry. So what we said was we have the positive and the negative connections. They correspond with pin 4 and pin 7 respectively. And so all I'm going to do, I'm going to take some wire links and I'm going to connect pin 7, which was my positive. It's going to go to the top rail, which is our positive 9 volts. And likewise, let's see if we can find, I haven't got a black, I'll use a white connection for the negative, going from pin 4 down to our negative rail. So notice it's not our 0 rail, which was the second last one. It's the negative, which is the very bottom row there. Okay, these are starting to fall out now. Next up, let's have a look back at our diagram. So we've connected our positive and our negative rails. Let's start having a look at these inputs here, these capacitors and these resistors. So first of all, we've got two resistors, R1 and R2. If we ignore these capacitors for now, it's just two resistors in series, R1, R2, into our non-inverting input, which is the positive connection there. Just bear in mind on some diagrams, these are the other way around, positive at the top, negative at the bottom. So make sure you've got the correct orientation. It's going at the positive, which is the non-inverting input of this amplifier. And on our pin out connection there, our non-inverting input is pin 3. So what I want to do, there's no sort of right or wrong way to do it, but the way that I would go about this is put these resistors in place first. So R1 to R2 to that non-inverting input, which was pin 3. So let's do that. I've got some resistors here. These are 1.2K resistors, which in the color code scheme are brown, red, red with a gold band in this case. So 1.2K or 1,200 ohms. They're shipped in these sort of like paper reels on either end. I'm going to take them out of there, but as I've mentioned in previous videos, one of the sort of pitfalls of this when breadboarding is some of the glue can sort of remain on the end of these pins. You can see some there, even that sort of residue. And so if you can, just to sort of scrape that off, as it can affect the sort of conductivity of the circuit and the connections and all that kind of thing. So just very quickly, I'm just going to sort of just use my nail and finger just to sort of scrape off that residue as best I can. That'll do for now. And what we're going to do is we're going to go, let's go backwards. So pin 3 was our non-inverting input. So again, counting along from the bottom, 1, 2, 3. There's our non-inverting input. And we've got a resistor in there. I'm just going to take it out to just a random point out here, really. So it's in its own sort of row. And then from that same row, another resistor, because they're in series, this resistor is now going to connect to this resistor. So anywhere in that same row, we've got another resistor. And again, I'm just going to take that out to another just empty row off to the side there. So there's our two resistors in place there. And what we have is a couple of things. We've got, let's look at C1 first of all, which connects from the midpoint of those two resistors. It connects to what is essentially the output of the op amp. So it forms this little loop here, and the output of our operational amplifier is pin 6. And so what we can do here, I've got a 33 nanofarad capacitor. And what I'm going to do is I'm going to take that from this midpoint to pin 6. Now, what I could do is I could sort of try and stretch these legs to go from, I'll just bring this closer if it's not clear, from pin 6, which is the second one in, all the way down here to this midpoint. I'm going to cheat a tiny little bit, and I'm going to use another wire link. I'm going to take that pin 6 there. So there's these battery snaps are falling out. I'll put them back in later. Pin 6. I'm going to take that and I'm going to put that in its own row here. So notice that row is not the same as the row that the resistor's in, because that would mess things up. It's in its own row, so nothing's connected to this end of the link yet. And from that link, I'll then, just for the sake of making things a little bit easier, I'll then connect that capacitor to the same row as the midpoint. So we have something that looks like that. So you can see that that end of the capacitor is in the same row as the link, which goes back to pin 6. So we'll go from pin 6 to the capacitor, through the capacitor to the same row as the midpoint of those resistors. So rather than just trying to stretch that capacitor all over that gap, which chances are the capacitor is going to end up touching other things when we start putting other components, I'm just using that link just to sort of jump from pin 6. We're bringing pin 6 over here, as it were, with the same result. C2, a little bit easier, goes from somewhere between R2 and the non-inverting input, and it goes to ground. Now remember, we've defined ground as that 0 rail. In our case, the second bottom rail on our breadboard, even though I've lost those battery snaps now, I'll put those back in later. So we had positive, negative right at the bottom, and then 0 was the second bottom. So we're going from the intersection of R2 and the non-inverting input down to ground, or that 0 rail. And so that's a nice and easy one to do. What I can do is, again, I've got some sort of glue or residue on this capacitor here. I can take anywhere on that same row as pin 3 and R2, anywhere on that same row as pin 3 and R2 is that connection point there. So anywhere on that same row, I can take that capacitor and I'm taking it down to the second bottom row there. So it's in the same row as pin 3, and it's going down to the second bottom row. I hope you can see that. Okay, so now we've got our 2 resistors in place, we've got our 2 capacitors in place, we've got our power supplies in place. There's one thing remaining, and that is this little loop here. This is our feedback loop, which goes to the inverting input. And so it goes from the output, which we've already said was pin 6. We've used this already for that capacitor C1. But we're going to use it again. Pin 6 is going to go around to the inverting input, which is pin 2. And that's a nice and easy one. We can just use another link to go from pin 6, which is that second from the right on the top. So remember, 1, 2, 3, 4, 5, 6, second from the right on the top there. So we're going from pin 6 round, we can just jump straight over the top to pin 2. So there it is, this one here, going to pin 2 from pin 6. Okay, so at this point, these battery snaps tend to fall out when I'm moving the circuit around, but at this point we're just about done. I'm going to put these back in. So we're going from positive 9 to 0, from 0 to -9. And so remember, the orientation of these is both the same. They're both red to the top. Red to black, red to black. So red is upwards in both directions. Else we'd just end up, if it was red, black, black, red, we'd have two positive 9-volt terminals, which we don't want. We want all of them to be negative with respect to 0. So there's our circuit complete. In this video, we're going to leave it there, but in the next video, we're going to connect some inputs of different frequencies, and we're going to start putting together some measurements of how this circuit behaves when we apply a range of different frequencies to it.